Hey everyone, let me hit you with one of the strangest facts in all of physics. Take any atom, cool it down, keep cooling. Take away every last scrap of heat until you reach absolute zero. The coldest temperature the laws of physics even allow. Colder than outer space. Colder than anything you could ever feel. And that atom is still moving, still vibrating. Not because you didn't cool it enough, not because some tiny warmth is left. It vibrates because the universe literally forbids it from stopping. Perfect stillness? Impossible. Silence? Forbidden. There is a minimum hum built into reality itself. Today I'm going to break down exactly why, step by step, and show you how this changes everything. Stick around, because this one will blow your mind. You probably remember from school, temperature is just motion. Hot things jiggle fast, cold things jiggle slow. At absolute zero, everything should freeze solid. Atoms locked in place like tiny statues. Zero temperature, zero motion. Clean, simple, satisfying. That's the classical picture from the 1800s, and it's completely wrong. Not a little wrong. Fundamentally, quantum mechanically wrong. Because when physicists in the early 1900s solved the math using quantum mechanics, something wild showed up. The lowest possible energy an atom in a crystal can have is not zero. It's a tiny but very real amount. Think of atoms in a solid as little balls connected by tiny springs. Classical physics says you can drain all the energy. Quantum physics says, nope. The ground state energy can never be removed. Ever. That's the floor. The universe's built-in hum. So why can't the energy be zero? This is where it gets beautiful. In 1927, Werner Heisenberg discovered one of the deepest rules in nature. You can't know both a particle's exact position and its exact momentum at the same time. The product of their uncertainties has to be at least h-bar over 2. It's not a measurement problem. It's reality. If an atom were perfectly still, zero momentum, and exactly locked in one spot, Heisenberg says that's illegal. The universe won't allow it. So the atom does the only thing it can. It vibrates with the smallest possible motion. It's not caused by heat. It's caused by the math of existence. Motion is literally baked into the fabric of reality. Let's make this real with the coolest example on Earth. Helium. Helium-4 is super light, and its zero-point energy is huge compared to the weak forces holding its atoms together. Cool it to absolute zero at normal pressure, and it stays liquid. It refuses to freeze. Every other element solidifies. You have to squeeze it with at least 25 atmospheres of pressure just to force it into a solid. The zero-point jiggle is so strong, it keeps the atoms from locking into a crystal lattice. No exceptions. Diamond atoms barely wobble. Lead atoms wobble even less because they're heavy, but they all still vibrate. Okay, so can we even reach absolute zero to test this? The third law of thermodynamics says no. You can't reach it in a finite number of steps. Every cooling method gets less efficient the closer you get. It's a law of nature. But we've gotten insanely close. In 2003, MIT cooled sodium atoms to 500 picokelvin. In 2021, a German team dropped rubidium atoms down a tower and hit 38 picokelvin. The coldest recorded temperature, colder than deep space, colder than the Boomerang Nebula. And those atoms were still moving from zero-point energy. We can't kill the hum. Now it gets even weirder, because zero-point energy isn't just in atoms, it's in empty space itself. In 1948, Hendrik Casimir predicted, take two uncharged metal plates in a vacuum, put them super close together. Quantum fluctuations exist everywhere, but between the plates, Only certain wavelengths fit. Less energy density inside. That imbalance creates a tiny force pulling the plates together. The vacuum pushes. Empty space buzzes. When atoms in a crystal vibrate, those vibrations travel as waves. We call those waves phonons. Phonons are the quantum of sound. At absolute zero, zero-point phonons still exist. The crystal never shuts up. Here's the practical payoff. At room temperature, atoms vibrate like crazy from heat, causing resistance. Cool it enough, and phonons help electrons form Cooper pairs. They move without scattering. Zero resistance. This is superconductivity. Recent breakthroughs are getting us closer to room temperature tech every year. Put your hand on the table right now. Those atoms are vibrating. Energy isn't stuff. It's a property of motion. The universe vibrates always. Not because something pushes it, but because vibration is part of its structure. Silence is impossible. The universe forbids it. And honestly, that's beautiful. Reality has a voice. Thanks for watching. Stay curious. I'll see you in the next one. Stay curious. Reality has a voice, and it has always been speaking.